Hi everyone, we are continuing section 3.3. So now we are moving on to the standard algorithm. So I wanted to point out before we do this, a mistake I made on the multiplication table from last time. So you can see right here on 10 times 10, I wrote it as 50. Yeah, but we're base 5, right? So that 5 should have carried, and this should have been written as 100. So my apologies on that mistake. Okay, so we wrote this multiplication table last time, but we didn't use it as much. So this time we're definitely going to utilize it a lot more in the standard algorithm. So like every algorithm, we're going to start by writing our numbers with the place values lined up. Okay, so the standard algorithm is how we multiply things now, right? It's the most common one that we use when we're not learning how to multiply. So we start with multiplying with the unit on the bottom, and we multiply up, and then we multiply by the second place value for the bottom number, multiply up. Okay, so the first thing we're going to do is we're going to take this 3 and we're going to multiply by 2. So we have a 3 times a 2, and so in our multiplication table, a 3 times a 2 looks like this 1, 1. So we're going to write down a 1 and then carry a 1. Okay, so we're going to carry a 1, and then we're going to continue. So now we do 3 times that 4. So 3 times 4 looks like this. Oh, not that one. Looks like this 1, 2. I'm sorry, looks like that 2, 2. So we're going to have 2, 2, and then we add 1, right? We're going to add this one right here, and then we get a 2, 3. Okay. So now that we've done the unit on the bottom, we can go, and now we're going to do the long on the bottom, that next place value. So I'm going to cross this out so that we're not looking at it anymore. When we cross that out, we put a 0 here for our placeholder, because now we're really multiplying longs, so we need to add a 0 for a placeholder. Okay, so we're going to go this 2 times 2. Well, 2 times 2 in base 5 just looks like 4. No regrouping necessary. Okay, and so now we're going to do the 4. I'm actually going to erase what we carried before. So we're going to do 4 times 2, which 4 times 2 looks like this 1, 3 right here. 4 times 2 looks like 1, 3. So we're going to have a 3 and then a 1. And now we just add these up. There was nothing to carry, nothing to add. So 1 times 0 is 1. 1 plus 0 is 1. My apologies. 3 plus 4 has 7, which has 1, 5. Which has 1, 5 and 2 left over. 1 plus 2 plus 3 is 6, which has 1, 5 and 1 left over. 1 plus 1 is 2. So this is how we multiply in the standard algorithm. You can see, well, let me write out the answer. So this gives us 4, 2, base 5 times 2, 3. Base 5 is 2, 1, 2, 1, base 5. Okay, and you can see this was a lot shorter, right, compared to adding up 4 or 6 partial sums. We only added 2 partial sums, and that made everything go a lot quicker. Let me just write these a little nicer. So that just made everything go a lot quicker. Yeah, but it was heavily impacted by using this multiplication table, right? We circled the different values that were important, and we used them because we had already taken the time before we started this problem to write out our multiplication table so that it would make solving the problem easier. Okay, so now we're going to do a little bit of a longer example. So instead of doing two two-digit numbers, we're doing 2 three-digit numbers. So we have 2, 4, 1, base 5 times 1, 2, 3, base 5. So again, we're going to start with the 3 in the units place. We're going to multiply up like so. Let me actually give myself a bit more room to draw these arrows. You don't have to draw the arrows. I just do because I'm writing on this tablet here and I can't show you what I'm pointing at. So I'm going to use these arrows and erase them periodically like I have been, just because we're constrained by me not being in front of you. Okay, so we're going to take the 3 and multiply up. So 3 times 1 is 3. And there's no regrouping. So we're just going to write down 3. Then we're going to do the 3 times 4. And we're going to go back up to our multiplication table. 3 times 4 looks like 2, 2. So we're going to take a 2, that 2, 2, write the 2 down, and carry the other one. So now we're going to do this 3 times this 2. So 3 times 2, going back up to our multiplication table, looks like 1, 1. So we're going to write down, we're going to take 1, 1, and then add that 2 to it. So now it's 1, 3. Okay, so now we are done with that 3. So I'm going to cross that 3 out and put a 0 as our placeholder, because we're completely moving on from it. And we're moving 1 place to the left. So I'm going to put a 0 to represent that shift. Okay, so now we are going, this 2 times 1 is just 2. Simple and easy. 2 times 4, if we go back up, looks like 1, 3. So we're going to put a 3 down and carry the 1 and erase this carrying from before. So we're going to carry a 1. So now we're going to look at this 2 times 2. Well, 2 times 2 is 4, and we add 1, that looks like 1. Oh, let me rewrite this for you a little better. So it looks like 1, 0. Okay, so now we're done with that 2. We've done it all, so we're going to erase the arrow, erase the carry, and we're going to cross out that 2. And now we've shifted 2 places to the left. Okay, so now we're going to deal with this 1. So 1 times 1 is just 1. That one was simple and easy, so we go to the next one. 1 times 4 is 4. And lastly, 1 times 2 is 2. Okay, so that was all. So now we've multiplied all 3 of those bottom digits. So now we can add everything together. So 300 is 3, 220 is 4, 331 is 7, which has 1 5, and there's 2 left over. 114 is 6, which has 1 5, and there's 1 left over. And then 112 is 4. So now we write our final answer. So we have 2, 4, 1, base 5 times 1, 2, 3. Base 5 is 4, 1, 2, 4, 3, base 5. Okay, so we had a lot of carrying going on here, and you can definitely see how having this multiplication table and referencing it and using it is really helpful when you multiply in different bases. It just makes things a lot simpler. Okay, so that was all for this algorithm. I know that your book doesn't deal with this multiplication in different bases as much, but I think it's really important just for us to remember what it felt like to struggle with these things. Okay, so the last video is the next one, and we're going to be talking about units and how important those are. So for now, that's all for this video.